This is question number 22 on the November 2014 calculator paper. Part A of this question says simplify fully, and we have two quadratic equations as fractions, one in the numerator, one in the denominator. So you should realize that you need to factorize both quadratics and then see if you can cancel something out. So we're going to do that. I'm going to rewrite the question first of all. So I'm going to rewrite 2x squared minus 5x plus 3 all over x squared plus 5x minus 6. And so in the numerator, I'll factorize it to get two factors. The denominator, I'll have two factors as well. Let's work out the numerator then. So I have 2x squared at the front. That means at the front of each of these, I will have 2x and x. That's the only combination that could multiply together to give me 2x squared. At the other ends, I will have 1 and 3. That's the only combination that could times together to give me 3. I need to get positive 3, but I also need to combine them in some way to get minus 5x in the middle. So I'm going to try different combinations here. And I'm going to try by putting a 3 here and a 1 here. I'm doing it in pencil so I can rub this off if necessary. So 3 times x is going to give me 3x. 2x times 1 is going to give me 2x. And together I could combine those two if they were minus 2x and minus 3x to get minus 5x. So in fact, I've got my results there. This is going to be minus 3 and this is going to be minus 1. Okay, and I just need to do a quick check to see if that works. Again, minus 3 times minus 1 is plus 3, so that definitely works. Checking all the others, that's fine. Looking at the denominator, I have x squared at the front, so that means I'll have x and x there. I have 6 here, and there are several combinations that I could use to get 6. So to get 6, I could have 1 times 6, I could have 2 times 3. And in fact, both of these in some way or form could give me positive 5. Okay, I could have plus 2 and plus 3, and I could have, let's see, plus 6 and minus 1. Both of those could combine together to give me positive 5x in the middle. However, I want to have minus 6 at the end. If they're both positive, that's not going to give me minus 6. And these two do times together to give me minus 6. So I'm going to put in minus 1 and plus 6. And this just doing a quick check. X times x is x squared. 1 times 6 is 6, and the signs are different, so it's minus 6. That's minus 1x, and that's plus 6x, which will combine to give me positive 5x. So that is correct. The other thing that tells me that I'm on the right track is that I have two factors, one in the numerator and one in the denominator, which are the same. So x minus 1 is going to cancel from the numerator and the denominator, and that's the bit that they want us to simplify fully. So my final answer is going to be 2x minus 3 all over x plus 6. Okay, if I just shuffle that across so you can see it. All right, so that's the full answer to this question. Make sure you do understand it. If I zoom out so you could see the whole thing. Okay, this is a straightforward question, right? And especially if you're aiming for the top grade, you should be able to do this without much difficulty. Going on to part B. In part B, the question says make M the subject of the formula. So we want to make it so that at the end we say M is equal to, and we have everything else on the right hand side which is not, or which doesn't contain M. Now looking at this expression, I have two M's in it, which means that it's one of those where I'm going to have to work it through and bring all the M's together and then tidy up. But before I do that, I have several terms in the denominators which I'm going to try to get rid of first of all. So I'm going to get rid of the V first from the denominator, then the B, and then the R. And to get rid of a term from the denominator, you times the whole expression, the whole equation, by that particular letter. So If I rewrite this expression first of all, this equation first of all, I have m over v minus t over b is equal to m minus t all over r. If I multiply everything by v first of all, so each term I'm going to multiply by v, and that's going to give me, so timesing this by v is just going to be m, the v's will cancel out. Timesing the second term by v will give me tv over b is equal to, and then times this term by v, that gives me v times m minus t all over r. Okay, so I've multiplied everything by v. Now I'm going to try to get rid of the b by the same process. I'm going to times by b each term again. So bm minus tv is equal to bv times m minus t all over r. Finally, I want to get rid of this r from the denominator. Again, I'll times by r, and that gives me bm r minus tvr is equal to bv minus bv brackets m minus t. Okay, so I've achieved what I wanted. I've gotten rid of all the denominators, and I've got this equation here. It has two m's in it. So the next stage is to multiply out these brackets and try to bring all the m's over to one side, and that's what I'm going to do right now. I'm going to leave the left-hand side as it is. bm r minus tvr is equal to, multiplying out this brackets gives me bvm minus bvt. I'm going to bring all the m's over to the left-hand side. So that means I need to take this term here across to the left, leave this one behind, and take tvr over to the right-hand side. So bmr is already here. When I bring bvm across, it's going to become minus bvm. If I take tvr across to the right-hand side, it becomes, from negative tvr, it's going to become positive tvr minus bvt, which is already there. I've got all the m's together, and now I can factorize, taking a factor of m out of this expression. I'll be left with br minus bv inside the brackets, and on the right hand side I have tvr minus bvt. I'm one step away from the end now. All I need to do is to get rid of this bracket, so I'll have m is equal to, and if I just move this up so you can see the full solution, tvr minus bvt all over br minus bv. So there is my result. That's what I write in the answer space, and that's making m the subject of the formula. What I am going to do is I'm going to zoom out a bit so that you could see the full question for part B. And what I am going to suggest is that you take your time, you go through it, you follow each step and stage. I just need to say here that my first three lines, I could have done them in one go by timesing everything by VBR in one go. So if I times each bit by VBR, I would have gotten to this line here straight away. But I've done it in stages so that you can follow it. Think about it, make sure you can do it, and please do make sure you can get full marks in it if you get a question of this type.